ladies and gentlemen. Welcome to 7.2. We're going to do some triangle trig today, some basic trig stuff. So let's start with this example. It says the Americans with Disabilities Act provides regulations designed to make public buildings accessible to all. Under this act, the slope of an entrance ramp designed for those with mobility disorders must not exceed a ratio of 1 to 12. So this means that for every 12 units of horizontal run, the ramp can rise or fall no more than 1 unit. And so we see that here in this picture. You're only going to go 1 here for every 12 feet this way. Okay, so our first question says find the length of the ramp. Okay, so we're going to just do our Pythagorean theorem here for that. So 1 squared plus 12 squared equals x squared. We're looking for the length of the ramp. That ends up being the hypotenuse. So I'll give you a moment to go ahead and finish that on your calculator. We do get a decimal, so this one, it looks like we should round it to about 2 decimal places. Just because it's a 0.4, you could round to 1 and say 12.0, just to note that that's a rounded answer. All right, so then it says find the measure of angle A. And so for this, we're going to use our trig. So remember sine, cosine, and tangent. So if we look at angle A is here. So 1 feet is my opposite and 12 feet is my hypotenuse. So based on our trig that we learned last year in Algebra 1, this tells us that we're going to use our tangent. So tangent of A equals 1 over 12. Now, it says tangent of our angle, and when we're finding our angle, we have to remind ourselves that we're going to use inverse trig, or inverse tangent to find a set angle. So whenever we're finding an angle, use the inverse. So A equals the inverse tangent of 1/12. Now, if you don't remember how to get that, hit second tan, and that is going to give you tan to the -1. Don't do tangent and then do your caret button to the -1. You want second tan. That brings you up that inverse. All right, so when you type that in, make sure that your calculator is in degrees, not in radians. So go to the mode, make sure degrees is highlighted, not radians. And we end up with this being 4.8 degrees. All right, so then that just brings us to this diagram. So it talks about our sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and our tangent is opposite over adjacent. New thing we're going to, I just do want to remind you that we often think of this as SOHCAHTOA. Okay, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So then what's the reciprocal? We're going to do a little work with these today. We have cosecant, CSC, cosecant. That's just the inverse of sine, the hypotenuse over the opposite. Then we have secant, which is the inverse, or the reciprocal, I should say, of cosine. So hypotenuse over adjacent, and then we have cotangent, so adjacent over opposite. So we're going to just do this little chart here where we get this triangle, right triangle, a 3, 4, 5 triangle, and we're just going to identify the sine, cosine, tangent, and then we're going to do the reciprocal of those for the other 3. So theta is up in the corner, so that makes 4 my opposite, 3 is my adjacent, and 5 is my hypotenuse. All right, so sine, we do that, we get 4 over 5. Cosine, we end up with 3 over 5. And tangent, we end up with 4 over 3. Now, the other ones we're going to do is we're going to find the reciprocal, so we're just going to flip our fraction. Keep in mind, if you get a radical, because you're missing a side, we're going to leave it as a radical when we put it into sine, cosine, tangent, cosecant, secant, and cotangent. So if we end up with a radical and it's in the denominator, excuse me, and it's in the denominator, we do have to rationalize that denominator. We'll do that here in a couple problems. All right. Then we go ahead, it says find cosine of A equals 2/5, or if cosine of A equals 2/5, find the value of the tangent of A. So what we're going to do is we are actually going to draw ourselves a triangle, and I'm going to call this corner A. I just usually drift towards using that bottom right corner. So cosine is our adjacent over our hypotenuse. So my adjacent is 2 and my hypotenuse is 5. So I want you to go ahead and do Pythagorean theorem and find our opposite side because we're going to need that to find the tangent. All right, hopefully you did that. If you didn't, pause the video and finish that up. And you find your opposite side to be the square root of 21. I cannot simplify that by pulling out any perfect square roots, so I'm going to leave it as the square root of 21. So now if I'm going to do the tangent of A, the tangent of A is going to be my opposite over my adjacent. So square root of 21 over 2. And that's where we're going to leave our answer for this problem. All right, so that brings us to problem 3. We're going to look at, it's a new triangle, and we're going to put, I'm just going to put a B down here, and we're given our tangent. So this is the opposite over the adjacent. So it means my opposite is 3, and my adjacent is going to be 7. Okay, go ahead and pause it here and do Pythagorean theorem to find our hypotenuse, because we're going to need that to find our sine. All right, you should have found square root of 58 for our hypotenuse. So sine is opposite over hypotenuse. So the sine of B is the opposite over the hypotenuse. But we know in our hearts that it is not an okay thing to leave that radical in the bottom. So we're going to rationalize the denominator. And so to do that, we times the top and the bottom of our fraction by the square root of 58. The reason why is because square root of 58 divided by square root of 58 is 1. So we're not changing the value of it. It's still worth the same amount, but we're just changing how it looks. All right, so we are going to go ahead then and get 3 square root of 58 on the top. When we take a radical times itself, the square root goes away and we get a 58 here. And then the last thing you always just want to double check is, can you reduce that coefficient and the denominator? So 3 over 58 does not reduce. So sine of B is 3 square root of 58 over 58. All right, so let's go ahead, solve for x here. It says x is my opposite of 20. 15 is my hypotenuse. So looking at your trig functions, opposite and hypotenuse, we are going to use sine of 20 equals my opposite over my hypotenuse. So if my variable is in the numerator, I'm going to times by 15 on both sides. And then, so I get x equals 15 times the sine of 20, and that's what you're going to go ahead and type into your calculator. Now, at this point, we are going to get a decimal answer, and that's okay. We just don't want to use a decimal answer like in our fractions. So here we get 5.13. Great. Problem 5 says solve triangle XYZ. So this means we're going to find all the values, the angles, and the sides that we don't know. So if we look at our angles, that's usually a nice way to start. And we're in luck. We know 2 out of the 3. In this, our triangle angles add up to 180. So we can just take 180 minus the 35 and minus the 90 to find angle Y. So go ahead and take 180 minus 90 minus 35, and we are going to find angle Y is equal to 55 degrees. All right, so that's an easy one. That one's out of the way. Let's go ahead and solve for, I'm just going to pick X. And so in relationship to the 35, X is my opposite and 10 is my adjacent. So I'm going to use my trig function of tangent. So tangent of my angle equals opposite over adjacent. Oops, over 10. So again, my denominator is where my number is and my variable's in the numerator. So I'm just going to times by 10 on both sides. So x equals 10 times the tangent of 35. Type that into your calculator to find an answer for x. All right, so if you type that into your calculator, we get rounded to 7.0. All right, I like to keep using my 10 when I find z. Some people will use Pythagorean theorem and use your rounded answer of 7. You're going to get very close to the answer that we get when we do trig. I just like to use my whole number instead of my rounded answer. So z is my hypotenuse. So I'm going to now use my adjacent and my hypotenuse. So that's going to be cosine of 35 equals my adjacent over my hypotenuse. Now this one looks a little different. My denominator is my variable. And so we can talk about that we times by z on both sides. And then you have to divide by cosine of 35 because that's gone. So we're dividing by cosine of 35. Or you can just remember the shortcut that your variable and your trig function just flip spots. So go ahead and type that into your calculator. And if we do that, we end up with 12.2. So we found all three of our missing places. All right, let's go ahead to word problem. So SOHCAHTOA is up on the top, so we're going to remember to use that. It says, in order to construct a bridge, the width of the river must be determined. Suppose a stake is planted on one side of the river and directly across from the stake on the opposite side. So at a distance of 50 meters to the left of the stake, the angle is 82 degrees measured between the two stakes. Find the width of the river. So really the picture is what helps us with this one. We have two stakes. They are right across from each other. And then we went 50 degrees to the left, and that created an 82-degree angle. We need to find W. So W is my opposite, and 50 is my adjacent. So my trig function, therefore, is tangent. So tangent of 82 equals my opposite over my adjacent. Perfect. My variable is in the numerator, so I'm just going to times both sides by 50. So I get W equals 50 times the tangent of 82. And go ahead and type that into your calculator. All right, and we get 355.8 meters for this one. So if we look at another problem that is, oh, I think that we are actually done with that. Okay, thanks guys.